This is a custom controller I built to fly a super fast FPV drone, and I'm gonna show you how. Now, I love FPV, but let's be honest, traditional transmitters are just not intuitive for the average beginner. What if a drone can just copy what I do? If I tilt left, the drone will roll left. If I tilt forward, the drone will pitch forward. If I twist right, the drone will look to the right. And the throttle gets controlled via a trigger. You get the idea. For this build, I'm using the following parts: a Teensy 4.1, an Adafruit BNO055, a 10K potentiometer, 2 momentary push buttons, a regulated 18650 power holder, and an RC radio to transmit the commands. So once I got all the parts, I brought in Codex. The first thing I did was give Codex the entire hardware list and asked it to make me a wiring diagram. Every port labeled, every wire color-coded, and every connection shown clearly so I knew exactly where to solder. And once the hardware is wired, it's time for the firmware. So basically the code needs to read orientation from the IMU, convert that into roll, pitch, and yaw data, read the throttle knob, and then convert all of that into PPM signals that my radio can actually understand. And I'm glad Codex can help me with that, because between you and me, my coding style is more like staring at errors and just crashing out. Alright, the code is uploaded, trainer mode is on, and the drone is connected to Betaflight. The real test is a receiver tab, and if the channels move when I tilt my controller, the signal path works. And there it is. Roll, pitch, yaw, and throttle are responding. But the first flight did not go as expected, because the controller works, but somehow that becomes the problem. Follow me for part 2 to see how I fixed it.